Welcome to an exciting educational video brought to you by Upvision Concepts Academy. So in this lesson, we'll be looking at solubility. And solubility is defined as the maximum amount of solutes that can dissolve in a given quantity of solvent at a specific temperature to form saturated solution. Actually, the formula looks like this. Solutes plus solvent will give us a solution. Okay, so this solute is like a solid, and the solvent is like a liquid, and the solution is the mixture of both solid and liquid. So I just call it an aqueous solution. So solubility is defined as the maximum amount of solutes. So the solid that will dissolve in a given quantity of solvent. Yes. This is very important. The solvent is measured, you understand, and you begin to put solid inside the solvent, and as you're putting solid inside the solvent, it dissolves. You understand? A time will come where it will be saturated that it cannot dissolve more. You understand? So solubility is the amount, is the maximum amount, you understand, of solutes that you can put inside a given quantity of solvent to form a solution. Okay, the standard units of solubility is gram per 100 degree, gram per 100 gram of solvent. So we can call this gram per dm cube. So these are the units of solubility, gram per dm cube. So solute is substance, like I said, it's like substance like a sugar or something, or like salt. And solvent is the one that dissolves as water. So example of what I'm saying. So if 36 gram of potassium what now? Okay, let me use nitrate. Potassium nitrate, okay, dissolve in 100 gram of water at 30 degrees. You see the condition at 30 degrees. Its solubility at that temperature is 36 gram per 100 gram of water. This solubility, just the ratio of the solutes to solvents. Okay, all right. So saturated solution is I can say that a solution is to be saturated when no more solute can dissolve in that solution in a particular temperature. So any additional solute will remain undissolved. That's what this one means. It is saturated. It cannot take more solute again. I said that you have a containing vessel and you have a standard, let's say 100 dm cube of water here. Begin to put solid inside, you understand? And it's dissolving. A time will come when you put additional solid again, it will not dissolve again because it's too saturated. It's overwhelmed. It can't dissolve. You know, the dissolution of this solid is like it's doing work. It's working to dissolve them as they're entering. It's accumulating and dissolving it. But a time will come when you add an additional one, it can no longer dissolve. That is saturation. But unsaturation or saturated solution is a solution that contains less solutes than it can hold at a given temperature. So it's said to be unsaturated. So even before it gets to saturation, it is unsaturated. Okay? So, but supersaturated solution, there's another concept I want to quickly define. Supersaturated solution. So this is a solution actually that contains more solute than the solvent can normally dissolve at a temperature. It is unstable and crystallization can easily occur. So this supersaturation leads to crystallization. Okay. So what I have on the board is called solubility curves. So solubility curves are graphical representation that shows solubility of substances as it varies with temperature. So in this y-axis, you have the solubility in grams of salt in 100 gram of water. And on this axis, x-axis, you have the temperature. Okay, so a point on the curve shows solubility at that temperature. So I have different salts here, different salts, and their graph. You can have more on this particular graph. You can even pick one and look at it. Understand? So the a point on the curve represents supersaturated solutions. Points above the curve. So for instance, now if I look at potassium chloride, anything above here is supersaturation, and anything under it is unsaturation or saturated solutions. So what are the key uses of this solubility curves? It compares solubility of substances. So we can see different substances here, different salts here, different salts here. I have calcium chloride, potassium chloride, sodium chloride, and so on. So we can predict crystallization for this with this, and then we can calculate how many solutes will dissolve at a given temperature. So for instance, like this one now, I can look at this one now and I say, okay, how many solutes will dissolve at this temperature? So this is the number of gram in 100 gram of water, and this is the temperature. So it varies with temperature. So factors affecting solubility, I can say number one, temperature. For solids in liquids, solubility generally increases with temperature. So when the temperature increases, the solution can, or the solvent can accommodate more solute. Okay. For gases in liquid, solubility decreases with increasing temperature. So you see there are two ways that affecting it. Temperature is affecting it in the sense that for solid in liquids, so if you have solid inside liquid, solubility will increase with increasing temperature. So the solvent can dissolve more with higher temperature. But for gases in liquid, solubility decreases with increasing temperature. Note this difference. Okay, another factor affecting solubility is nature of solvents and solutes. Okay, what does that mean? If you want to dissolve polar solute dissolve in polar solvents. Okay, well, polar has to do with the kind of bond that is existing in that solution or solvent. Okay, so pressure is another factor that affects solubility. Pressure. For gas solubility, gases dissolve more in liquids under high pressure. That's Henry's law. Henry's law. Okay. All right. So we have seen that temperature, nature of solutes and solvent, and pressure affects solubility. So crystallization is the process by which a solute comes out of solution in the form of crystals when a saturated solution is cooled or solvent is evaporated. So what are the steps? The steps to do crystallization is number one, prepare a saturated solution of a solute. Then number two, allows it to cool or evaporate slowly. Third step, crystals form are collected via filtration. Crystals are dried to obtain pure solutes. So you see the process. Number one, steps. There are 4 steps. Number one, prepare a saturated solution of the solutes. That's the first step. Number two, allow it to cool. Allow it to cool or evaporate slowly. Now, at higher temperature, you see that solute, that solvent can accommodate more solutes. But when it cools, it now reveals the solute in form of crystals because the temperature is cooled. You know that solubility curve that we drew, most of them are going up. Why? Because the higher the temperature, the more solutions or the more gram of solute can be dissolved in 100 gram of water. Okay, so if you drop the temperature, the crystals begin to come out. Okay, so that's the third point. Crystals are formed and are collected via what process? Filtration. And finally, crystals are dried and obtained as pure solutes. So what are the importance of these steps? The importance of these steps, crystallization steps. Number one, we use it for salt recovery. We use it in recovering salts. Number two, it is used for purification of substances. And number three, separating mixtures in labs and in industries. So I'm going to leave some NECO-style questions on the description or on the comment. You have a lot of them. Just go through them. Go through this video. It's very important. Go through this video and then go to the questions. The answer to the questions are also in the comment section. Just engage us, like the video and share it. Subscribe if you're not subscribed. And I hope this video has been informative for you. I'd like to thank you for viewing.